Hello and welcome. My name's Andrew, and this is going to be the first video of the channel, as well as the first video of the organic chemistry series. In today's video, we're going to be talking about alkanes, the simplest hydrocarbon referring to a molecule composed of carbon and hydrogen atoms. Alkanes specifically are the most saturated hydrocarbon, meaning that the carbon atoms are sp3 hybridized, which means that it is completely saturated to its fullest extent with hydrogen atoms. Carbon specifically has 4 valence electrons, so that means it can bond to 4 hydrogen atoms in alkanes because they're fully saturated. So the general formula for alkanes, you're going to be coming across this plenty of times in organic chemistry or other courses as you move along through college or wherever you may be wanting to learn this. So the general formula is CnH2n plus 2. This accounts for its full saturation. So as we move into naming, we use the IUPAC naming system in organic chemistry. I think of it as a 4-part system. When naming alkanes, as well as alkenes or alkynes, alkenes being hydrocarbons containing double bonds, pi bonds, and alkynes, which contain 2 pi bonds, making a triple bond, you use a 4-part system. First, you have a locant. A locant refers to where are the substituents and functional groups. Coming after a locant, you have a prefix. A prefix refers to what are these substituents. Do you have an alcohol? Do you have an aldehyde, a ketone, etc.? Next, you have the parent chain of carbon atoms. So this is where the prefixes get put into play. Depending on where you take organic chemistry, who your professor is, however many of these prefixes you have to memorize is completely dependent on that. I, as a general rule, like to memorize between 1 and 20, but if you can memorize between 1 and 10, 1 and 12, you're perfectly fine moving forward in organic chemistry. One carbon atom refers to a methyl prefix, meth prefix, eth, pro, bute, pent, and that's 2, 3, 4, 5, respectively. Memorizing these is key. So let's hop into some practice problems and put the steps into play. Number 1, when naming compounds, first thing you want to do is find the parent chain. Find the longest chain of carbon atoms. So when we look at this molecule, we see clearly that there are 1, 2, 3, 4, 5 carbon atoms. Each ending and vertex in the skeletal structure refers to a carbon atom. We infer the hydrogens. We know that the carbons are sp3 hybridized, so we know that on each carbon atom, there are 3 on the end carbon atoms, In naming this compound, we go back to the prefixes that we learned. We know that we see 5 carbon atoms here, so that means pent is the prefix, and because it's an alkane, we name it the ending ane. That is the ending, pentane. There's 5 carbon atoms, pentane. So, next example. Let's go back to the rules. Find the longest chain. We got 1, 2, 3, 4. Now, this one's a little more confusing than the last one. We see that we have 2 substituents on this molecule. We have a chlorine atom, and then we have a methyl group. So, where do we name? From what side do we name? In this molecule, you name from this side, the side with the chlorine. So this molecule is named 2-chloro-3-methyl. And because there are 4 carbon atoms, it gets the ending butane. This one we got two different substituents on it. Two different ones in the last one. We have an ethyl group, which is CH2, CH3, and then here we have an alcohol. In naming this alkane, the alcohol gets an ol ending, OL. So, go back to the steps. Step 1, number the carbon atoms. Number from the side with the first substituent closest to the end, and number the longest parent chain. 1, 2, 3, 4, 5, 6, 7, 8. So this one, this molecule, will be named 6-ethyl. Ethyl 2-oct, because there are 8 carbon atoms, octanol, because it's an alcohol. 6-ethyl 2-octanol. All right, next molecule. This one, we see we have 3 substituents. We have one right here, and then we have another right here, and another right here. You may be wondering, how do we go ahead and name this? Go back to the rules. We got to make sure to number the longest parent chain. 1, 2, 3, 4, 5, 6, 7. So notice this is hept. That's the prefix. Hept for 7. So now we look at the substituents. Where are they? Which one's closer to the end? This one, carbon. So this one gets named 3, 4, 4, trimethyl. Heptanol. Not heptanol, heptane, excuse me. So we have 3, 4, 4, trimethyl heptane. Okay, so next example. This one's a little bit easier than the last one. We see that we have 2 substituents on this molecule. The first order of business is numbering the longest parent chain. So we got 1, 2, 3, 4, 5, 6. So we know this is a hex. It has to be a hex prefix. Next, we see we have 2 substituents, one on the third carbon atom and one on the second carbon atom. So, pause the video, name this molecule, and then check in with me. So this one would be named 2,3-dimethyl hexane. 2,3-dimethyl hexane. All right, last example. First order of business, number the molecule. So we look to the side that will give the first substituent the lowest number, which happens to be this side. 1, 2, 3, 4, 5, 6, 7. So now this is a hept molecule, hept for 7. Now we turn and look at the substituents. This one is a methyl group. This one, although different than what it looked like before, is an ethyl group. We have CH2, CH3, the CH2, and then the CH3. So how do we name this? Go back to the alphabetical rule. So when we name this, it'd be 4-ethyl, because E comes before M, 4-ethyl, 3-methyl, heptane. Heptane because it is 7 carbon atoms in the parent chain. So I hope that video helped. We'll be also uploading an alkene and alkyne nomenclature video very soon, maybe even with this video. So if this helped, make sure to comment, like, subscribe for more content, and leave any comments with any concerns, or maybe if I messed up something in the video, make sure to leave me some supportive criticism so I can fix that for the next video moving forward. Thank you. See you in the next one.